properties of real numbers. We can actually relate the properties of real numbers in real life situation. For example, when we buy something in the supermarket, let's say you will buy UFC, ketchup, and Nova. Do you think the total price that you need to pay the cashier will matter if you lend first the UFC or you lend the Nova first? So let's say yung friend mo sasabihin na, yan yung bigay mo muna yung Nova kasi mas cheap, mas less yung amount na ipipay natin if yung Nova yung ibibigay natin first. I guess you would agree that it will not matter. The order will not matter here. So whether UFC comes first or Nova comes first, you will be still paying the same total amount. Contradictory to that, let's have the situation of wearing your socks and your shoes. So is it okay that you wear your shoes first and then your socks? I guess your answer is no. You always wear your socks first and then shoes afterwards. Your socks will not fit if you would like to wear your shoes first and then your socks. It will not fit at all. So, contradictory to the situation in the grocery or in the supermarket, you can just interchange them. But here, you cannot. Same thing happens when you try to do something with integers. So, for example, in multiplying 12 times 4 times 3, you can you can actually multiply first 12 times 4 and then 3. Or you can multiply 3 times 4 and then 12. So for example, let's deal with 12 times 4. 12 times 4 is 48. 48 times 3 will give you 144. But what if instead of multiplying first 12 times 4, we will multiply 3 times 4 first and then multiply it with 12? So let's try. 3 times 4 is 12. But 12 times 12 is also 144. So if you notice, the result is the same. Whether we multiply first 12 times 4 or 3 times 4 first. But there are also cases like this. For example, in dividing, 14 divided by 7 is 2. But if we would want to interchange 14 and 7, 7 divided 14 will be 0.5. So, interchanging the two numbers will not be the same. So, why do we do this? So, of course, the properties of the real number system, the ones that we will discuss now, will actually help you to work with equations, functions, and formulas in algebra in the future, because as they allow you for the creation of equivalent expressions which will often aid in solving problems. So it's like saying that when you know how to deal with properties of real numbers, you will be able to manipulate equations, expressions in which you will be able to solve them easier compared to the traditional way. And lastly, they can be used to help explain or justify your solutions. So when you do something, you just don't randomly do any steps. You follow certain mathematical concepts when you do something. And properties of the real number system will definitely help you to reason out. that what you're doing is really correct. Let's start. So basically, let's try to look back something from grade school. So for sure, your teacher will always start with manipulative objects, like for example, apples. So you can see that there are four apples here. So the quantity can be represented by 4. And that 4 in the situation is a real number based from our lesson this quarter. Specifically, it's an integer, but it is also a real number. So we will elaborate more about, we will further discuss about real numbers in the next set of lessons. So now, the numbers that you see, 4 and 0.3, are real numbers. And when you try to add them, this would be our lesson in the future. So what matters most is that you acknowledge that both numbers are real numbers. So when you add both, 4 plus 0.3 is 4.3. So take note, 4.3 is also a real number. So what does it mean? 4, which is a real number, added with another real number, will give you also a real number. This is closure property of addition. Why of addition? Because you're adding. So let's try another example. 2 and 1/4 are real numbers, so take note of that. But when we try to multiply 2 and 14, what will happen to our two different real numbers? 2 times 1/4 will result to 1/2. Before we continue, I would like to emphasize something that you would want to apply in the future. So in grade school, you usually use x as your way to communicate to someone that you're referring to multiplication. But here in high school and then the rest of your journey in mathematics, sometimes we do not confuse ourselves. And most of the time, we use this symbol in algebra and it's very common, which is your x. So this might give you confusion whether it's times or the variable in algebra or the letter x. So that's why instead of using the x symbol for multiplication, we usually use parentheses. So when we enclose two different real numbers inside parentheses, and then there's no operation between them, it pertains to multiplication. So again, take note of that. So going back, 2 times 1/4 is 1/2. Okay, so we will learn about how to multiply these numbers in the next set of lessons. But for now, when you multiply 2 and 1/4, that's a 1/2. And that 1/2 is also a real number. So that means when we perform multiplication to 2 and 1/4, which are the real numbers, it would also give you a real number. That means it's closure property of multiplication. So let's try to generalize all numbers that we know, all the real numbers that we know. So we usually use a letter as a symbol that this letter, letter A, can be any real number that you know. It can be 5, it can be 6, it can be 8, as long as it's a real number that you know so far. Same with B. So think of any number that you can actually interchange with A and B. So whatever that real number is, if you try to add them, it will still give you a real number. Or even multiplying them will still give you a real number. So as I was saying, this would be an advanced lesson A, B, and C, and D, and the other letters in the alphabet are used to represent a real number. These are called variables. So meaning A can be any number that you can think of, B as well, C and D. Okay, let's proceed to our second property. So take note, 10 plus 5 or interchanging them will not matter because whether you say 10 plus 5 or 5 plus 10, the result would still be 15. It's like saying 10 apples added with 5 apples. If you put them together because it's a concept of adding, still it's a 15. Or you say there are 5 apples and here comes other 10 apples, you put them together, it will still give you 15. That means you are applying the concept of commutative property of addition. The whole concept here is very simple. It says that the order will not matter when the operation is addition. That's commutative property. So what if it's multiplication? 10 times 5, based from your multiplication table, I think it's under 10. So 10 times 1 times 10 times 2. So the ones that you've memorized, 10 times 5 is 50. But in the set of 5, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And so on. But 5 times 10 is also 50. That means that multiplication is commutative. So commutative property of multiplication, whether you interchange the two numbers, but as long as the operation is multiplication, the result would still be the same. And that summarizes the two, the property number two, which is commutative property of addition and commutative property of multiplication. So the A and B here can be any real number that you know. Sir, how about if it's subtraction or division? So to answer that one, uh, they are not commutative. Why is it that they are not commutative? Because if we try to recall from our lesson, let's say you have 2 minus 3. Based from our lesson before, we have to copy the 2 and then the subtraction becomes an addition and then get the opposite of positive 3, which is negative 3. Then follow the rules in adding integers, different signs. That means subtract the absolute value of the two numbers. 3 minus 2 is 1. Then absolute value of negative 3 is 3. Absolute value of 2 is 2. 3 is greater than 2. So we follow the sign of the 3, which is negative. So that's a negative 1. But if we interchange 3 minus 2, 3 minus 2 is just 1. So they're not the same anymore. Okay? So same with our example a while ago. How about division? 14 divided by 7 is 2. But 7 divided by 14 is 1 half. Because the concept of division, remember, if there are 14 and you try to group together 7 or you distribute them equally. So you have 7, 7. So there are 2 7, so the answer is 2. But 7 divided by 14, that will not work. But instead, it will give you an answer which is in decimal. So, commutative property is only applicable to addition and multiplication. So let's try to apply the concept here. So 7 plus 3 is just the same as 3 plus 7 if you apply commutative property. Because 7 plus 3 is still 10, 3 plus 7 will still give you 10. So this is commutative property of addition. Second one is 7 times 3. Meaning, if you apply commutative property, you can just interchange 3 and 7. And then, if you try to simplify this, 7 times 3 is 21. 3 times 7 is also 21. Okay, now let's go to the third property. So if you notice, we already use a grouping symbol. So the parenthesis is an indicator that you need to priority whatever is inside it before doing something outside. So, so again, what if we would not follow that, but instead we change the priority? Instead of adding 4 plus 7 and then 3, what if we add 7 and 3 first and then add 4? Do you think the answer would be different? Let's check. 4 plus 7 is 11, right? And add 3. 11 plus 3 is 14. That's correct. Here, 7 plus 3 is 10. For now, it seems like they're not the same. But when you add 4 and 10, that's also a 14. So, that's the next property, associative property of addition. But again, the operation must be all addition. So it's okay to priority other numbers first and then change if you want the priority. The answer would still be the same. How about if it's multiplication? Let's say 4 times 7. That's what you need to do first. Then that is also an indication of multiplication, okay? So, what if, again, there's a fast trivia here, that this symbol is also an indication of multiplication. A dot in between. Here, in between. What if, instead of multiplying first of 4 times 7, you will multiply 7 times 3 first? But again, the order did not change. It's just that you're changing the priority. You're changing what is inside the parentheses, but you did not move the arrangement of the given. Okay, let's check the result. If we have 4 times 7 first, 4 times 7 is 28. And then, what is 28 times 3? It's 84. Here, we multiply first 7 and 3. 7 times 3 is 21. But 21 times 4 is 84. And they're the same. That's why multiplication, associative property, will apply to multiplication as well. So here's a summary of associative property of addition. You can just change the priority group, but as long as the operation would all be addition. Same with multiplication. If the operation would be all multiplication, and then you can just change whatever's inside the parentheses. You can change whatever is the priority. Let's try some example. change the grouping of the numbers, then evaluate. So here, the grouping is 3 plus 5. And you have plus 4 outside. That means you can change what is inside the parentheses back. But again, we did not rearrange the numbers. So instead of placing 3 and 5 inside, we placed 5 and 4 now inside. So based from our simple concept a while ago of parentheses, prioritize whatever is inside it. So 3 plus 5 is 8 plus 4. And then 5 plus 4 is 9. But 8 plus 4 is 12, as well as 3 and 9, so 12. How about 5 times 6 times 7? So you need to prioritize 5 and 6 first. So instead of multiplying 5 and 6, we multiply first 6 and 7. And to do that, you have to enclose it inside the parentheses. So now, since 5 and 6 is our priority, 5 times 6 is 30. But here, our priority is 6 times 7. So 6 times 7 is 42. But 30 times 7 is 210. And 5 times 42 is also 210. Okay, now, we have here distributive property. So what is the complete statement of distributive? It's actually distributive property of multiplication over addition. But why? Because as I said a while ago, if there is a number and there is a parenthesis after it and there's nothing between them, meaning the operation is multiplication. So this is a multiplication. And inside the parenthesis, there are two numbers and they are grouped together because of the parenthesis. And the operation is addition. So that's why it's multiplication over addition. But what do we do now? From the word itself, distribute, we just have to distribute the A to both numbers inside the parentheses. Only if the operation is addition. So take note of that. Do not forget. Only if the operation is addition. So that would become A times B, A times C. And we copy the addition between them. So same if there's a group and then the number is after it and there's no operation between them. Still, that's multiplication. And there are two numbers separated by addition. So we distribute A times B. Take note, this is just commutative. So it will not matter whether we write first B with A. And then A times C. So that's why you have CA. And then copy addition. Okay, let's try to apply that. Let's apply the distributive property, then evaluate. Let us try to check what will happen if in case we follow the traditional way and then the concept of distributive. So when we apply the concept of distributive, meaning we distribute the 2 to 2 and do 2 to 3. Okay, but in the traditional way, you need to add first 2 and 3 because it's inside the parentheses, right? But 2 plus 3 is 6. Take note. And then 2 times 6 is 12. Okay, let's check what will happen here after we distribute. 2 times 2 is 4. 2 times 3 is 6. 4 plus 6 is... I wait. 2 plus 3 is not 6, but it's a 5. I wish.